Alright guys, so what I've got here are three different twist lock type adapters that go from 2" to 1¼ inch. One is by Antares that you see here. The middle one is Celestron, and the right one is William Optics. Now what I've decided to do here is, you see the order: Antares, Celestron, and William Optics. What I've done is I've started from the cheapest of the group to the more expensive, and that's the order I put them in. So the Antares that you see on the left, that was $29. I bought that from Scope Stuff. In the middle, you see the Celestron at $39.95, and I bought that from Adorama Camera. And then the one on the right is the William Optics. That was bought from Ageno Astro Products at $50. Now I did do a review here a few weeks back of the William Optics, an extensive review of it, and I'll put a link to that. And once I bought that, I thought, let me look at a couple other ones just for the heck of it, and see how they're built and see how they work. Again, I was very happy with the William Optics. In fact, I bought a second one, and eventually I want to put one on every scope. And so again, I thought, let me look at these other two and just see how they work, how I like them. And again, that'll be my personal opinion. Some people may like one or the other, and I'm going to test them with various eyepieces. Now as you see them sitting here, it's with everything that came with them. The Antares came with a cap, kind of a unique type cap. The Celestron did not come with any kind of a cap, and the William Optics came with a cap. Now all three of these are a little bit different in the way they operate. They all twist. You turn these, if you turn them clockwise, they will clamp down onto your eyepiece. Counterclockwise will release it, and you'll be able to pull the eyepiece out. So, but they all do it just a little bit differently. The two closest are going to be the Antares and the Celestron. As far as the mechanisms, the William Optics is totally different. So let's take a look at the Antares. And again, it came with this cap with a hole in it. Now when I look on the website, Scope Stuff, it doesn't say anything, but this is basically like a what I would call a sighting cap, because you see that little hole in there. When you've got a reflector, back in the day my largest reflector was a 12.5" Starliner, oh god, in the early 80s, and you would use this to put your eye up against. I would center dot the mirror, and then when you do all your aligning, you would use this. Then the very small opening kind of gets you centered to where you need to be. So I kind of like that. Again, it's out of a hard, it's not flexible, it's a very durable plastic cap with that hole. So that's kind of interesting. And just for the heck of it, what I have here, if you guys remember back in the day, Coulter Optical, they had like a 13, I think, and a half inch or a 13" reflector, really cheap, with kind of a pipe mount, and then they had a 17 or 17.5, if I recall. So anyways, this is what I was using in the day. And prior to this, I had an old Ramsden eyepiece. I don't even know how many millimeters, from Edmund Scientific, that had a little bit bigger hole than this, and I just pulled the optics out and used it when I got better eyepieces. So I just thought that was interesting of the Antares. Now the Celestron did not come with any protective cover or plug. And your William Optics, it came with this type of a plug. So that way, these are nice to have, so that if your eyepiece or diagonal is not in the scope, you want something to keep dust out, which isn't a big deal with this. I have other ones, but I just thought it was interesting that it did not come with one. Now as far as terminology, the Antares, the description is a 1.25 inch to 2 inch low profile twist lock adapter with wide compression bar. And the Celestron is a 2 to 1.25 inch adapter with twist lock. The William Optics is a 2 to 1.25 inch Rotolock eyepiece adapter, and it is in red. I believe it comes in a couple other colors. Now I'm on Scope Stuff's website, and we see that the one that I bought on the Antares is an ADP5. Says it has a 0.6 inch diameter wide compression band that solves problems caused by safety recesses on some eyepieces. Testing here shows that these adapters hold eyepieces very securely, even those with undercuts. 1.25 inch barrels align very true to the 2 inch outside barrel. And one thing to take note of that I thought was interesting, also has male T-threads if you remove the twist ring, so it doubles as an emergency adapter. So that has the male T-threads. Quite interesting. And let's look at that. Here's the Antares. We're going to take this. It's got a lot of threads. So if we take this off, those are actually T-threads right there then. Now this is a 2 inch filter on this Antares, and you can see it's not threaded all the way down. It's saying that it's threaded for standard 2 inch filters. This does not go on worth a damn. Okay, this is just, it just isn't going on very good at all. You can see there. Yeah. It's terrible, so it fails that part of the test as far as I'm concerned. Now here's a close-up of that threaded area on the Antares. Well, this is the number on the Celestron twist lock. It says made in Taiwan. Now here's a standard 2 inch filter on the Celestron, and it goes down all the way, and it's butter smooth. Now here's a close-up of the threaded area on the Celestron. Here you see the 2 inch standard filter on the William Optics Rotolock, and it is very smooth, goes down all the way, no issues. Here's a close-up of the threaded area on the William Optics. Now here, guys, we see them apart. And when I had said earlier that the Antares and Celestron were somewhat similar in the fact that they use one ring, one compression ring, different materials, different design, but they just use one ring. Okay, the Antares, Celestron, William Optics. The William Optics, you'll notice, uses 3 different rings. This ring and this ring are split rings, compression. The center one has the ramp on it. I'll show you that when these two that go on, this goes on one side, this goes on the bottom side. When you turn this down, it compresses both the bottom and top rings. So you've got 2 different distinct rings that do the compressing. Whereas with the Antares and Celestron, you have one wide ring. Now as far as the Antares and the Celestron, the top end where the ring, where the twist ring goes, there is no grease. the William Optics does have a liberal amount of some type of grease on the threads. Now for the following examples of the rings, I'll be using this Teleview 9mm Delight eyepiece. Here you see the Antares ring, and the way it came off is that notch that you see to the left side here, that was up. The taper is down, and it has to be that way because there's a taper built into the adapter back here, and I'll show you that when this is forced down, it will ramp down and close this collet, which will in turn clamp down on your eyepiece. So you'll see, here's what the 9mm looks like. You'll see what that'll clamp onto. That's the amount that it'll clamp onto. Now all these Televiews do have undercuts that I'm going to be using here today to demonstrate. And you'll see right there, see where that shiny stuff is, see where that's at right here? That's where, when you put this ring in, and they're all going to act basically the same. When you push that ring in there, and you push down, effectively pushing down with this top ring nut, you'll see that? As you push down, that allows that to compress, effectively clamping your eyepiece. Now the Antares ring is supposed to be made out of some type of graphite material. Alright, with the same 9mm eyepiece, let's look at the Celestron. Here you see it split. Quite a bit different construction than it's ribbed. It's got these 3 ribs, basically. And you'll see how that will clamp onto your eyepiece. And again, this has the exact same principle. It's got the taper on both sides. So when this pushes down, pushes that in, clamps on. Now the big difference is the Celestron is aluminum. Much more rigid to push on. Alright, so now, going to the William Optics, you've got to put this ring on first. Then you have the solid ring second. And then the bottom ring third. So effectively, you're clamping 2 different areas. You're clamping up at the top and clamping down at the bottom. And the William Optics rings, they are all aluminum. Tapered both sides. This is tapered on the inside. The solid ring is tapered on the inside to receive this ring. Same thing for the back side. And the same situation for the bottom split ring. So let's put these back together. Here, in this view, you get an idea as to the heights, approximate heights. and the thickness of each locking top piece, and the construction. The Antares has the thinner ring, which is grooved. The Celestron is wider, also grooved, and the William Optics is scalloped out and grooved. Next, I want to do a test of the clamping pressure of each one of those twist lock devices. And I'm going to start out with the 18mm Radian. Then we're going to try the 9mm Delight, and finally the 3.5mm Delos. All three Teleview eyepieces. So we will put the 18mm Radian in. I'm going to hold the base and just simply twist this and do no more than that much of a lock. And then basically I'm going to see how good this holds. As you can see, it's not. And I'm not putting that much pressure on it. This is the extended eye shield, so I have to pull that up. And there you see it. And it stops right there. So let's try cranking it. That's about as tight as I can get it. Look, I got it a little bit tighter. But again, when you're on your, if you're doing this at your telescope, you're not going to be cranking it down. I wouldn't assume, or shouldn't have to. Now let's see what happens. It still slips a little bit. This is the Antares again. Yeah, it still slips. All right, the 18mm Radian with the Celestron. Wow, that pulled out real easy. Let me crank on that a little bit more. That's about as tight as I can get it. There's only so much leverage you're going to get on here with your hands. Okay, when I cranked it down, yep, that's it. Had to put a lot more pressure on it. Next is the William Optics. Of the three, this is the easiest to tighten. And it's probably because it's scalloped out like that. You can get your hands in there, your fingers. And I have arthritis. Every now and then, depending how it is, it's hard to turn things. So right from the get-go, this is the easiest of the three to get a good positive tightness on it. And I cannot pull that up. And I am pulling. Yep, that's good. Next, we're going to do the same thing with this 9mm Delight, starting out in the Antares. And as you can see, it pulls right out. I really can't tighten it any more than that. There's only so much grip I can get on this. Now, the question becomes, if you're just using this as an eyepiece, will it come out all the way? Probably not. If you're using this with a heavy camera. So, again, I'm just trying to see what the clamping pressure is. And I had to put quite a bit of torque on there, and it still did not do well. Alright, the 9mm with the Celestron. I'm going to crank on that a little bit. Let's see what happens. and it pulled out a little. Again, same thing with the Antares. You know, will it hold? Yes. If you have a heavy camera, this did not slide as easy as the Antares. This held better. And the William Optics with the 9mm. And again, this is just so much easier to tighten. I don't know what else to say. It's just so much more positive. So much easier. And I am pulling on that. And it is not releasing, boys and girls. Alright, the Antares 3.5mm Delos, if I'm pronouncing that correctly. And we will, I'm gonna crank on this. That's as tight as I can get that. And it moved a little bit, it slipped. I mean, very easy. 2 fingers and just pull on it. Very poor gripping power, in my opinion. The Celestron. I turned on that, I tightened that pretty decent. And that's holding. That's holding. Cannot get it to come out. And I'm pulling on it. So that's good. The William Optics. Again, butter smooth action. For me, extremely easy to tighten this down. Doesn't take a lot of effort. And I am pulling on this. And it is not going to come apart. So next the question becomes, well, all my Televiews, 1 1/4" have some form of an undercut. So I've got some Explorer Scientifics that are straight, no undercuts. We have a 20mm, we have an 11mm, and let's see how they fare with those. So here's the 20mm Explorer Scientific. And I'm going to tighten this down. It's about as tight as I can get it. There's only so much grip you can get on this ring. And let's see what happens. Pulls right out. Same thing. Also guys, that 20mm Explorer Scientific does have that same, I think you can see the transition point there in the light. Does have a very, very slight taper going from larger here to smaller as it gets to the back part of the eyepiece. Very, very slight. Celestron. And I'm going to crank down on it. It's about as tight as I can get it. A little bit. That's interesting. Does move. William Optics. And I'm pulling on that, and it is locked. Locked and loaded. Next, let's try the 11mm Explorer Scientific, because this has a longer barrel on it, and there is just, you can kind of feel right here a transition point. You might be able to see it there in the light. right at the end of my thumb there, my fingernail, there's a transition, just a slight taper. So let's try that with the Antares. And I'm going to, tight as I can get it. Now that's on there. Yep, that's tight. So that's interesting. It looks like the Antares, it's going to depend on how much it's gripping on the barrel and whether or not it has undercuts. Now you recall, going back here to scope stuff, testing here shows that these adapters hold eyepieces very securely, even those with undercuts. 1.25-inch barrels align very true to the 2-inch outside barrel. The Celestron and 11mm Explorer Scientific. It's about as tight as I can get that. And that is also holding. Yep, will not come apart. So again, guys, it's looking like with the Celestron also, depends on the barrel design of the eyepiece. And finally, with the William Optics, and I am pulling. Well, guys, like I said in the beginning, I'll let you decide what you think. That's why I wanted to go through this test of the various different kinds to get a good feel for how they hold. And again, to be fair, will these all hold an eyepiece? Yes. Is it a bit brutal to maybe try to pull on the eyepieces? It might be. But again, in practice, they'll all three hold an eyepiece. I don't know if you put a heavy camera in there, will they slip depending on what position your telescope's in. But for me, the superior one is the William Optics. Second is going to be the Celestron. And coming in a very far third, and I mean far, is the Antares. One of the extreme negatives was it hardly held any eyepiece well. And the fact that the threads are so very, my Batter 2-inch filter, and I tried a couple other ones, did not accept the filter well at all. Didn't want to thread. I didn't want to do any damage to the filter. So this does not pass at all, in my opinion, okay, the Antares. I'll hang on to it, if for nothing else. As it said, it's got the T-threads up here. I may find down the road that comes in handy. But again, for me, the clear winner in this test is the William Optics. So hopefully you enjoyed this, and choose wisely.